Hello out there, welcome to this tutorial on geometry of a straight line. This is part 4 of this tutorial. Check the description section of this video on our YouTube channel to get the link to other videos on geometry of a straight line. In this video, we'll be looking at parallelism and perpendicularity of two lines. So we start the conditions for parallelism and perpendicularity. Given two lines AB and PQ with gradients M1 and M2 respectively, AB is parallel to PQ if they have the same gradient. That is, M1 is equal to M2. So we then say AB is parallel to PQ. AB is perpendicular to PQ if the product of their gradients is negative 1. That is, M1 times M2 is equal to negative 1. So we look at this, we then say PQ is perpendicular to AB. So they are perpendicular to each other. So these are the conditions we are going to be making use of in this tutorial. So we then start with problem 1. Problem 1, state which of the following pairs of lines are parallel or perpendicular or neither. So we have A, B, and C here. So starting our solution from A, we have 4x minus 2y is equal to 9 and y is equal to 2x minus 7. So we start with the first line, which is 4x minus 2y equals 9. We are going to express it in standard form of linear equation by making y the subject of the relation. From there, we'll be able to get our gradient. So taking this to the other side, we have negative 2y is equal to 9 minus 4x. So dividing through by negative 2, we have y equal to 2x minus 4.5. So since negative 4x divided by 2 will give us 2x, and 9 divided by negative 2 gives negative 4.5. So we can see now from here, the gradient of this line, which is the coefficient of x, is 2. Then we go to the second line, which is y equal to 2x minus 7. The equation of this line has already been expressed as standard form, where our M2 is 2, since gradient is coefficient of x. So we can see now that the gradient of the first line and the gradient of the second line are equal. Therefore, the lines are parallel. That's all for A. We then go for B. We have x plus 7y is equal to 21, and the second line is 6x minus y is equal to 7. For the first line, we make y the subject of the formula again. 7y is equal to negative x plus 21. Dividing through by 7, y is negative x over 7, then plus 3. 21 divided by 7 gives 3. So from here, our gradient is coefficient of x, which is negative 1 over 7. Then also for L2, we have 6x minus y is equal to 7, making y the subject of the formula. Take this y to the other side, we are going to have y to be equal to 6x minus 7. So again, our gradient for this second line is 6, which is the coefficient of x. So you can see now that the gradients are not equal, and at the same time, their product will not give us negative 1. So we conclude that the lines are neither parallel nor perpendicular. And that's all for problem 1b. We then go to 1c. So our first line is going to be x plus 5y minus 15 is equal to 0, making y the subject of the relation. 5y is equal to negative x plus 15. Dividing through by 5, y is equal to negative x over 5 plus 3. 15 divided by 5 gives 3. So again, the gradient of the first line is negative 1 over 5. that is the coefficient of x. So for the second line, we have 2y is equal to 10x minus 9. What we just do here is just to divide through by 2. So we now have y equal to 5x minus 9 over 2. So again, the gradient of the second line here is 5. First, they are not equal, but we test for perpendicularity, that is m1 times m2, which is going to give us negative 1 over 5 times 5, and that gives negative 1. Therefore, the lines are perpendicular. That's all for problem 1c, and the end of solution to problem 1. We then go to problem 2. For problem 2, find the equation of the line passing through 2, 5 and parallel to 3y minus 12x is equal to 4. So in our solution, we are going to have the first line, which is 3y minus 12x is equal to 4. We make y the subject of the formula to get the gradient. So we have 3y is equal to 12x plus 4. Dividing through by 3, y is equal to 4x plus 4 over 3. So our m1 here, the gradient of the first line, is the coefficient of x, which is equal to 4. And since they are parallel to each other, we now say m2 is also equal to 4. So that to get the second line, this is a case of a gradient and one point, which is a form of forming a linear equation. You still remember our formula? Y minus y1 is equal to m into x minus x1. Here our m is 4, that's for the second line, and our x1 is 2. Finally, our y1 is 5. We then substitute into this to give our equation. So we have y minus y1, that is minus 5, is equal to 4, since m is 4, into x, then minus 2. So we expand this bracket, y minus 5 is equal to 4x minus 8. So we take this to the right hand side. We are going to have y equal to 4x. Negative 8 plus 5 will give us negative 3. And that's the equation of the line passing through 2, 5 and parallel to 3y minus 12x equals 4. So we then go to problem 3. For problem 3, find the equation of the line passing through negative 1, negative 3 and perpendicular to 2x plus 3y equals 10. So in our solution, we look at the first line, which is 2x plus 3y equals 10. Make y the subject of the formula. So 3y is equal to negative 2x plus 10. Dividing through by 3, y is equal to negative 2x over 3 plus 10 over 3. So from there, we now get our gradient of the first line, which is negative 2 over 3. And since the other line is perpendicular to this particular line, the gradient, which is m2, now is going to be positive reciprocal of this, which is 3 over 2. Then we omit the minus, because if you multiply these two, it will give you negative 1. And that's the condition for two lines to be perpendicular to each other. Then we go for the second line, and the second line is passing through negative 1, negative 3, and the gradient is 3 over 2. So it's a case of one point and the gradient, and this is the relation where our m is going to be m2, which is 3 over 2. Our x1 is negative 1, y1 is negative 3. We then substitute into this relation to get the equation. So y minus negative 3 is equal to m, which is 3 over 2 into x minus negative 1. So expanding this bracket, so minus minus gives plus, so we have y plus 3 is equal to 3 over 2 into x plus 1. So we cross multiply, 2 into y plus 3 is equal to 3 into x plus 1. Expanding the bracket, 2y plus 6 is equal to 3x plus 3. And then we take this 6 to the right hand side. I have 2y is equal to 3x minus 3. This is going to give us 3 minus 6, which gives negative 3. And we can also leave the equation in this form, which is the equation of the line passing through negative 1 comma negative 3 and perpendicular to 2x plus 3y equals 10. And that's the end of solution to problem 3, and this is the highest we can take in this tutorial. I hope you enjoyed it. Thank you for watching. Don't forget to check the description section of this video on our YouTube channel to get the link to other videos on geometry of a straight line. Until we come your way again, goodbye.